In this series in our recordings of CAM Assist integrated in SolidCAM, we're going to show you working with small diameter end mills, and we'll also be using two different setups, one for this side and one for the flip side as well, as we have some pockets to be milled out over there. Also note that we have very small corners. We have a corner over here that's 2 millimeters in a radius. And if I even flip this over to the flip side, you can see we even have a space over here with the total width of the space is a total of 3.5 millimeters. So we have to use pretty small end mills. Now note, when using small end mills, it's also important to pay attention to the height of the end mills themselves, how much is sticking out of the holders, and actually to see if it has enough support, because CAM Assist takes that into account when it chooses a tool to use. Okay, so let's get started. Let's first take a look at our actual toolkit, and if we take a look at the toolkit, you'll see that we have a chamfer mill, we have some small drills over here, we have a larger end mill, and then we have smaller ones, a 6 millimeter. We even have a 3 millimeter, a 4 millimeter. And if we take a look, for example, at the 3 millimeter end mill, you can see that this is actually pretty short with a 6 millimeter shaft, giving it more support. Okay, so let's start running our CAM Assist. I'll right click on Operation and then run CAM Assist. Again, we'll let it run. It checks out what is feasible, and it sees that everything can be machined, no issues detected, and I will be working in metric, so I'll put that to metric. And now we'll go to prepare. When I go to prepare, first of all, it sees that I have two different setups for the part. Also, if I take a look at my tools, all my tools have been accepted. It picked up every single type of tool that I have, including the 3 millimeter end mill with a 6 millimeter shaft. Okay, I'm ready to run CAM Assist. As it's running, it's going through checking to make sure what strategies it can use, what the surfaces that it has, the ones that it can work on, the ones that it can't work on. And what's nice also that it shows you in the unfinished exactly what cannot be worked on because of the type of tools that you may have. Okay, just to take that into consideration. Take a look also at the programs to see what kind of strategies it will be using. We'll be using in the first setup facing, roughing, flat finishing, wall finishing, hole making, spot drilling, boring, all these different types of operations. And in the second setup, you can see it's also doing a whole bunch of different types of operations. Okay, all I'm going to do now is send it to SolidCAM, and let's take a look at the operations that it created for us. You can see it's first going through the first setup, creating the operations for the face mill, iMachining 3D with several different end mills, starting with the larger one and going down to the small one. And we'll see that in a few moments also during our simulation. It's doing all the different pockets with all the different sizes that it may need to finish off, including those corners. It's doing also the drilling operations that's needed, and the counter bore does that with helical boring into the tool itself. And on the flip side, again, it does iMachining 3D, then the floors, and then it finishes off the part with the walls, and also always deburring those edges. Okay, so everything basically is done. We'll do a quick calculation of everything. And as it finishes calculating, it's now going over to the second setup, working on the iMachining on that side, finishing off the floors, and then also doing the deburring at the very end. Let's take a look at this simulation. And you can see that it first does the face mill, does the iMachining with a larger end mill, with a 10 millimeter end mill that I had inside my toolkit to get out a nice amount of the material. When it finishes iMachining with this particular tool, it'll then use a smaller end mill to get into areas where that larger tool cannot go, and even after that, we'll even use a smaller end mill for the really, really small corners that we have in the part. You can see that being done now with this end mill, and all of the corners are machined. It'll then finish off all the faces that need to be finished. Also doing with the smaller end mill, certain faces that need to also be finished in order to get to those corners. And now working on the flip side for setup 2 to finish off all that excess material that's on top, to mill around into those pockets where it could not get to before. Here as well. And you'll note also in a few moments that we had those small areas that need to be machined out. So it will be machined out as well with a smaller end mill. As soon as it finishes with this end mill, you can see that this one finished off almost into that corner, and then going even with a smaller end mill to finish off all of these corners itself, including that area which I mentioned before, which is only 3.5 millimeters in distance from one to another. And there we have it. The part has been machined out. In our next recording, we'll be showing a little bit more about indexial machining.